Hey, what we'll do here is we'll continue with what's in the measurement and calculation section 2 or part 2, whichever way you want to look at it. And what we haven't done is we haven't really looked at this calculation piece. So what we want to do is take some values, some metric values, some base unit values, and be able to convert them quickly and easily to other base unit values. So we want a couple things when we're looking at this. We want to know what our base units are, and this is just a standard table of base units. And obviously there's derived units as well for things like volume that we'll be using. Actually, why don't we add that to the list? So these are our base units, but we do have derived units. We have units of volume. Volume, if we're using solid volume, we'll typically talk about it in square meters or square, be an area. For volume, cubic centimeters. Or if it's liquid, typically we're going to use milliliters as our major base unit for volume. Again, this is a derived unit. We also talk about density quite a bit. And there are other things that we are going to look at. But density typically is going to be grams per cubic centimeter or grams over cubic centimeters. So just another couple other units we want to be aware of that are what we refer to as derived units. They're derived because they're not from the base. The base unit, notice for volume, would be meters. But if we're talking about cubic centimeters, well, then we've changed those units slightly, so they're derived. One thing we want to know or be aware of is that any of our prefixes, any of our metric prefixes can go with any of our base units or any of our derived units. So notice, for example, here when I'm talking about volume, when I'm talking about solid volumes, I'm talking about cubic centimeters. Well, these could be cubic centimeters. I could also have nanometers cubed, right? So nano, if I'm talking about something really small, a very small volume, maybe it's cubic nanometers. A very large volume, maybe cubic kilometers, right? So any of these prefixes can go with any of the base units, and all they mean is what value these things are, how big or small they are. A lot of times what we'll have is we'll have tools that will measure, say, milliliters. So we're doing a certain experiment and we need 15 milliliters of water. So we'll measure it in our graduated cylinder, we'll take 50 milliliters, but then later on we'll have to use that in some calculation. And the calculation that we'll use, and a lot of times this happens, will require the base unit of milliliters. Well, the base unit of milliliters is liters, so it's milliliters. And so we'll want to convert this into liters, okay? So we need what's called conversion factor. So in the second step is going to go our conversion factor. Conversion factor. And we really do not have to memorize these. Sooner or later you will, because some of these we use so often that you will memorize these conversion factors. At the beginning, don't worry about memorizing them. We'll just pick them right off the table. So here's what we have. We have milli right here. A milli means 10 to the negative third. So going back here, 10 to the negative third, not meters, sorry, 10 to the negative third liters would be 1 milliliter, right? We can also write this the opposite direction, or I shouldn't say the opposite direction. We can show you where all the zeros are. So obviously if this is negative third, that means it is 0.001 liter in every 1 milliliter. So it's telling us where to put the decimal. So this is what I'll put in as my conversion factor. And again, you could use this either way. I prefer it as the exponent. I know some people do not. So if you want to convert it into just the decimal place, you can. I'm going to throw this in there. And so I'm going to draw a line. I'm going to multiply by this conversion factor. Now what I have to do is I have to look at whatever units are here, and I have to put the same ones on the bottom. So milliliter. And it's 1 milliliter because, again, that is just what I'm reading off the table. That's what this means when I look at it. When it says 10 to the negative third, it means that base unit is, one of the base units is 10 to the negative third of the prefixed unit, milli. So 10 to the negative third liters is 1 milliliter. Now notice what's going to happen. If I multiply this across milliliters, I'll divide those by the milliliter units down here. Now milliliters divided by milliliters is, well, the same thing as what's x divided by x is 1, and 2 divided by 2 is 1. So milliliters divided by milliliters, well, that'll just be 1. Those things will cancel out. That is the trick. That is the trick of unit conversions here. So milliliters cancel. I get 50 times 10 to the negative third. Notice liters is here. That's why I get liters as my final unit. And if I make myself some room here, I have an answer of 50 times 10 to the negative third. That's all I really need, right? But what would it be? 0.05 liters, or 5 times 10 to the negative second, if you want that as well. Either way, doesn't matter. Let's do some more, though. Say a milligrams, because sometimes things might be measured in milligrams. I have 1,000 milligrams, and I want to convert that into my base unit of grams. And notice I never give myself enough room. Okay, so now I need to look up that prefix unit. Well, notice the nice thing about it is it's still milli. Now we're not talking about milliliters, but we are talking about milligrams. So that's the thing is about our prefix units. They go across all of our base units. So 1 milligram, just like 1 milliliter, is 10 to the negative third grams. So notice what I'm doing. It's the exact same thing. Times by my conversion factor that's going to take away these units, 1 milligram. And it's going to give me the units I want over here, grams, times 10 to the negative third, grams on top. Okay, notice what happens. Milligrams will cancel with milligrams. I'll get 1,000 times 10 to the negative third. Well, 1,000 times 10 to the negative third, that is 1. There we go. Nice. But obviously we can do things other than milligrams, right? Say we had a centimeter. Well, let's go to something bigger. Say I had a kilometer measurement. It's 2 kilometers. But my equation, again, calls for an answer in the base unit in meters. So now I need to convert my kilometers to meters. So I'm going to go back to my table and see what 1 kilometer is. I need to look up my conversion factor. Because, again, I'm not memorizing them. I need to look them up at this point. So 1 kilometer is, on my table, find kilometer. And notice there's a lot of stuff, yotas and zetas, and most of these we're not going to use. They're just kind of for fun to look at. But we will use like kilo and milli and micro and nano even. So there's some that we really should know here. There's a lot that we probably aren't going to run into, but they're nice to be aware of. We'll reference them. We'll look them up on the table if we ever do need them. But I'm looking at kilos. So 1 base unit now is 10 to the third kilo. So a kilo is bigger than our base unit. So a kilo is 1,000 meters, right? 10 to the third, or 10 to the third meters, whichever way we want to think about it. Again, some people don't like the exponents. I do, just because I don't have to draw as many zeros. But if you want to convert it between this and this, that's perfectly fine. There's nothing wrong with that. All we have to do is make sure our unit that we're getting rid of goes underneath this. So we can get rid of it, and the unit we want goes on top, 1,000 meters. 2 times 1,000 is 2,000 meters. Kilometers cancel out. See, it's starting to get kind of easy. Let's make it harder. So it's also very possible that we might have to go across units. We might have to go from one prefixed unit to another. Say we had a number, I'm just going to use an easy number, 2 centimeters. And if I'm taking 2 centimeters, I want to convert centimeters into those kilometers. I want to see how many kilometers is 2 centimeters. So what I'll do is write down my 2 centimeters. And now what I'm going to tell you is if you were ever going from a prefixed base unit to another prefixed base unit, let's go through whatever that base unit is, meters. So I'm going to convert centimeters into meters, and then meters into kilometers. So really 2 conversions. So I'm going to leave my space here for 2. And it's going to equal something in kilometers. So that's what I want to end with. First, I have to get rid of centimeters. So first, I have to look up what that prefix unit is. And if you go and look that up, back on the table, you'll notice that 1 centimeters is 10 to the negative second meters. So again, the centimeters goes on bottom, because that's what I'm getting rid of. 10 to the negative second meters goes on top. Now again, if I look up kilometers, like I just used it, well, I know that 1 kilometer is 10 to the third meters. So where does that go? Well, now notice at this step, my centimeters have canceled. Now I'm in meters. So that's the new unit I'm trying to get rid of. So I'll put 10 to the third meters on the bottom. Again, the only way I can put that in is if I put in the top piece, which is 1 kilometer. And now notice what I have. My meters will cancel. And I'll have 2 times 10 to the negative second divided by 10 to the third. And what we end up with is So when we run this calculation through, now that we've looked up our conversion factors, again, this one's going here, we're canceling out our centimeters to get meters, and now this meters is canceling with this meters to leave us with kilometers. I have 2 times 10 to the negative second divided by 10 to the negative third. That's going to give me 2 times 10 to the negative fifth. And you can use your calculator. You really shouldn't need to. I didn't use mine. Or we could write it at 0.00002 kilometers. Once we get numbers that small, it's really preferable to use scientific notation. So some people might still be struggling with this. So let's think of a kind of an analogy of why we might want to do this. Let's say we're trying to do something like this. We want to know how many seconds are in, say, 2 years. I have 2 years left. I have 2 years left of high school. How many seconds do I have to spend here? So 2 years. I don't know how many seconds are in 2 years. I don't know how many seconds are in 1 year. But I could start this as the same way via this dimensional analysis problem-solving process, which is really what this is. It's just a problem-solving process. So I do know, what do I know? I know how many days are in a year. So 1 year is 365 days. And we'll assume there's no leap years here. We're going over normal years, or if we want to be really accurate, maybe 365.25 days, or 2461 or something, if you really get too accurate. But we'll call 365 good. 1 day. So that takes care of my years, by the way. My years are taken care of. Now I'm in days. Now I don't know how many seconds are in a day, but I know how many hours are in a day. There's 24, I believe. There's still 24 hours in a day. And again, that doesn't take me directly to seconds, but I know that there's 1 hour is 60 minutes, right? And if I can squeeze it in here, 1 minute. Yeah, I don't have to. Oh, maybe now I'm going to have to write sideways. 60 seconds. See, that's the problem with this conversion, is it takes up too much space. But notice days will cancel with days, hours with hours, and minutes with minutes. And now we get left with an answer in seconds, and all we have to do is multiply across to find that answer. So we get something like, well, let's call it 6.31, and I'm not going to write out all the numbers, but how about 6.31 times 10 to the 7th seconds, if I round it off there. So notice, again, it's just a problem-solving process. Getting rid of the units we want, solving for the units we do want. So let's do a couple with some derived units. And there's one in particular we want to look at, is we want to go back to look at milliliters. Because a lot of times we want milliliters, and we're going to convert between a liquid volume and a solid volume. So if I have milliliters, that's typically a liquid volume. But sometimes I would want it in a solid volume. And the solid volume we typically use is cubic centimeters. Well, there's a nice conversion between these. Is that 1 milliliter is 1 cubic centimeter. They're the same volume. If I have a liquid measure of 1 milliliter, it's going to take up the same volume as 1 cubic centimeter. 1 centimeter. Again, 1 cubic centimeter, remember what this means, just so we know what we're talking about with solid measurements, is 1 centimeter box, right? Length, width, times height, 1 cubic centimeter. If I constructed my little box out of wood here, and my box, and I poured in a liquid, the amount of liquid that would fit in there would be 1 milliliter. So this allows me to convert between liquid measurements and solid measurements. So a lot of times, that's all you'll have to do. It'll say, oh, 100 milliliters, what's that in cubic centimeters? Well, again, I'm going to use the same conversion process. 1 milliliter is 1 cubic centimeter, or 100 cubic centimeters. And again, some people don't like to do this because they know it's 1-to-1. I still want you to put it in, because occasionally, you'll have things that are a bit more crazy. Occasionally, you'll have, say, I'm going back to that 50 milliliters, and you'll need to convert it into cubic meters. Sometimes when we talk about gases, we talk about cubic meters. Well, I don't know how many milliliters are in a cubic meter, but again, we just said that 1 milliliter, that's supposed to be a milliliter, I apologize. 1 milliliter is 1 cubic centimeter. Again, how does that help me? Not quite too much right now, but I have it converted into, into solid volume measurements, just like this is. And I know there must be some relation between centimeters and meters. In fact, I remember 1 centimeter, if I go back and look at that chart, is 10 to the negative second meters. Or, again, you could flip this around, which I end up doing a lot because I don't like using negative exponents. That 10 to the second centimeters would be 1 meter. So if we just divide that 10 to the second to the other side, we get 10 to the second centimeters, or like we probably refer to this more often, 100 centimeters in 1 meter. So that's what I'm going to use. And that's my conversion factor, so I'm going to put in 100 centimeters in 1 meter. But there's something you have to be careful of here. This is 100 centimeters in 1 meter, but notice we have cubic centimeters. So this will work to cancel one of those. I still have cubic centimeters squared up there. Okay, this is not a volume measurement, this is a length measurement. This is a volume. Volume is length times width times height. That's how we get our cube. So if I convert this once, I'm really just converting for one dimension, just in the length dimension. So I have to do this again. That will take care of the other one. And one more time for 3. And I'll erase that. So, a little tricky, but not really, because notice, again, the problem kind of solves itself, because notice what we get. We get cubic centimeters. We get meters times meters times meters, meters times meters times meters is cubic meters. That's how we get a volume measurement in the first place, is by multiplying length units together. Now, notice we have 50 divided by 100 divided by 100 divided by 100, or 50 times 10 to the negative, how many zeros is that? 1, 2, 3, 4, 5, 6 times 10 to the negative 6th, or probably 5.0 times 10 to the negative 5th. It's probably the more accurate way to represent that. Okay, so let's just get, let's start getting kind of crazy with this. Say I measured a density, and we know what densities are. Densities are mass per unit volume. So I measured the density in lab. I could mass something. Okay, here's a classic way to measure for density. So I'm measuring the density of this rock. Notice I have my density calculation. Not that I need it, because I know it's grams over my volume measurement. So I put this rock on my scale. Notice I get it 482.63 grams. Again, if I wrote down the error on that, it'd be plus or minus 0.01 grams, right? Because that's the smallest unit that's there. I'm actually going to just make sure I keep track of what that error is. And we'll include it here on the end. Now notice I throw it into a graduated cylinder, and we see that the volume goes up. Notice it started at 600, it went up to 800. So 800 is my final volume. Volume final. If I subtract that, subtract my volume initial, minus volume initial, so minus 600, well, that's going to give me the amount that the volume changed. The change in volume, like it says here, is the volume of my rock. So it is 200, what units? This is in milliliters. And what would be my error, by the way? Well, this only goes up by every 100, so really it would be plus or minus half the smallest gradient actually would be 50. So it's not a very accurate scale, right? When you're only going up by 100, it's, for an analog scale, it's half the smallest gradient. The gradient is every 100. Half of that would be plus or minus 50. I'm a messy writer, I apologize. So anyway, we have our mass, which is a very accurate number with a very tiny error, and we have our volume, which is a not so accurate number with a huge error. So these are kind of goofy tools to use together, because you're using something really accurate and something not very accurate. But anyway, we can solve for the density. So 482, like it says, and we'll divide it by 200. So I'll just take this number over here, divide 482 by 200, and we get an answer that comes out to be, what, 2.41315. Now, a couple things here we might want to say is that we're probably going to drop off some of these numbers. Notice this does have 5 significant figures. We'll talk about 5 significant figures here in another podcast, or about significant figures. This is 5. This has fewer. So I'm going to cut this number off. For our conversion purposes, let's use 2.4 grams per 1 milliliter. That is the density, right? because I divided grams by milliliters, so it's 2.4 grams per milliliter. Now what I want to do is I want to represent this answer in different units, in kilograms per liter. Okay, so it's in grams per milliliter. I want kilograms per liter. It's actually the same thing. We just have units on the top and units on the bottom. It's no different than the conversions we were doing before. So first, I'm going to take care of those grams units. I know there's 1,000 grams in 1 kilogram, because 1 kilogram is 10 to the third. I'm just going to put in the zeros there. So notice I've already solved part of my problem. I've changed grams to kilograms. So I have kilograms per milliliter if I stop right there. I want to change, again, my milliliters to liters. Okay, so that's not too terribly bad. Milliliters is smaller than a liter. It's 10 to the negative third. Or again, if I convert that, so 10 to the negative third liters is 1 milliliter. That's what's on my chart. But again, what I do a lot of times, if it's a negative, I flip it to the other side, so I can have a positive exponent, because I don't like working with those negative exponents. Or 1 liter is 1,000 milliliters. Okay, so 1,000 milliliters goes on the top, and this time the one I'm getting rid of goes on the top because milliliters here is on the bottom. Milliliters, milliliters. Now notice what I have left, kilograms over liters, which is what I want here. Notice what else, 1, 2, 3 zeros, 1, 2, 3 zeros. Notice the density in kilograms per liter is exactly the same, 2.4 kilograms per liter. Now, stay tuned, because in the next podcast, what we're going to look at is we're going to look at how many numbers we should actually keep in that answer. Because here, notice we have a lot of accuracy with a very low error. Here we have very little accuracy with a pretty big error. So we would have to have a discussion about how many values can we actually represent in our answer. And that's what we're going to talk about in our next podcast. Stay tuned. Don't get too excited. You can't watch it yet. Wait. Soon you can watch it.